So the correlation coefficient, we're going to typically deal with R, which is the sample correlation coefficient. In fact, that's all we really talk about in this class, but you do need to know that rho, which is the Greek R, but it looks like a little P kind of, that is the population one. So you only need to know that, but we're never going to be calculating it or anything like that. The correlation coefficient is the strength of the relationship.
Like power?
Kind of like power, like how strong the points are between each other. So just looking at the points. So something is stronger if the points are closer together. Something is weaker if they're further apart. And then the direction, it's either positive or negative. That's your direction. So if your correlation is increasing or decreasing.
Is there like tests you can run, like kind of like it was like alpha significance of like it had to be above 0.5?
There are, but we don't do them in this class. AP Stats does it. So, some facts about the correlation coefficient. Correlation is always a number between -1 and +1. And then based upon that number is whether it is weak, moderate, or strong. So, here we have -1 to +1. In the middle, we have 0, which means no correlation. If it's exactly 0. If it is anything between -0.5 to +0.5, we consider that to be weak. So if it's exactly 0, there's none. If it's anything between -0.5 and +0.5, excluding 0, then that means that it is weak. Anything from 0.5 to 0.8 and -0.5 to -0.8, we consider that to be moderate. And then anything from 0.8 to 1 and -0.8 to 1 is considered strong. So basically, you can have negative strong and positive strong. And that just means like the direction in which it's going. But that also depends on how closely the points are related. So it doesn't matter what direction it's in. If the points are really closely related, that can still be strong. So we got some practice last time looking at graphs or looking at scatter plots and deciding or ordering them from weak strong to positive strong. So you guys were kind of ordering them without even knowing the numbers. Well, now we'll have the numbers, and so that'll be more helpful.
So it's like exactly one of those besides 0. What, like say it's like exactly.
It will never be like exactly 0.5. Like it'll be 0.502 or something. So it'll always be extended a few decimal places.
Like
if it were, then it wouldn't matter either way. Like I would accept both of them.
Moderately.
So if you had a correlation of exactly -1 or exactly +1, that would mean that it would be a perfect linear relationship. So if I took a sample and I surveyed husbands and wives, and I found out that every single husband is exactly their wife's age plus 2 years. So they're all exactly 2 years older than their wives. And that would be a direct, perfect line. A correlation of 1. Exactly. Because every single person that I surveyed their husband was 2 years older than the wife.
Oh, that's why. Y then X plus B.
Exactly. The sign indicates the direction. So we said again, I cannot stress this enough, that it's a positive correlation if the sign is positive, and if it's a negative R, then it's a negative correlation, which seems pretty intuitive, but people forget it.
You gotta check.
You gotta check.
Wait.
And the correlation of 0 doesn't necessarily mean that it doesn't, like, the points are not related. It just means that there's no linear relationship. So that means that they don't form a line. They could form a curve. So we're going to look at some examples in a minute and have a correlation of 0. Even though they look like they're really related, it just means that they're not linearly related.
Is that a word?
Linearly?
Yeah.
That is a word.
Is funner a word? I didn't think
It
so.
just looks like you made it up, kind of.
Maybe I
You have a
did.
blanket on?
Yes, I'm cold. Okay, so
I'm hot.
here's some pictures of, this one is R equals 1, so it's perfect. 0.9 is strong positive. 0.4, they called it moderate. I would say it's more weak. So let's change that to weak. Perfect negative. This is R equals -1, so it's strong. Strong negative, negative 0.9. Let's change this to weak. This one is R equals 0, and this one is also R equals 0. And why is the last one 0?
Curve.
It's curved, yeah. So even though the relationship looks good, it's not linear, so it's curved. So here are 4 facts about R that I could ask you about.
Oh, you need to study this.
So you're gonna ask.
So I could ask you. So R, the correlation, is not changed by any linear transformation. So write that down, and then let me talk about it.
And basically that last one.
What last one?
Curve.
No, it doesn't have to do with
That's what
curve.
I'm saying, bro.
Oh, is that like when you shift the line over like 2, but it still stays the same slope?
Yeah, so let's say that I took a sample here and I said, tell me how many hours you studied and then tell me what grade you got on the test. So it looks something like that. I'm just going to ballpark. Then, so this is hours and then this is grade. Then I said, okay, I'm just going to be generous today, which never happens, but let's say I did.
Happened one day.
And I
It happened.
shifted everyone's grade plus 5 points.
We should do it.
So what happens is now everybody is up here. They go up 5 points. So it's the orange. The R value, like let's say it was 0.72, I don't know. The R value doesn't change just because I added 5 points to everybody's grade. Because it's the relationship between the points themselves. So the points are still just as close together as they were before. Or if I subtracted 5 points from everyone's grade.
Let's not do that.
Same thing. Or if I multiplied everybody's grade by 2.
Yes.
Please.
It would not change. No.
It would change.
Okay, the second one says that the R does not depend on which variable is labeled X. So basically, if I switch my scatter plot and I put hours here and grade here, that would not affect my R value.
Oh, like if you switch to X and Y, it wouldn't matter.
Yeah, so if I switch X and Y.
Wait,
Because it's still the relationship between the points.
but it wouldn't make it.
No. Because if your grade is increasing, your hours are increasing. Still a positive relationship. Just switching the X and Y. The value of R is, so circle the word is whenever you write it. It is affected by extreme values. So what I mean by that is somebody is an outlier and they did not study at all, but they got 100 and they're out here. So this person is 0, 100 right here. That's their point. That skews the data. They skewed everything up. And so that's going to weaken my correlation. Like, I'm trying to make a point here that the more you study, the better grade you get. But then this person right here ruins my point because that weakens my data. So if it's an outlier, it's going to weaken it. So outlier weakens. But then, if it's on the line or it extends the line, so then somebody comes in and they studied 0 hours, but they got a 0. So they're right here. That proves my point, and so that strengthens it, which makes me happy. Right?
That makes you happy. Somebody got a 0 on your test.
So if it adds to the line, then it strengthens it. Like the more data I have, there's like strength in numbers. So the more I'm adding to it, it strengthens it. If it is smack dab in the middle, like, I don't know, 5 and they made a 50 or something. I don't know. If it's smack dab in the middle, if it is smack dab in the middle, then it really doesn't affect it at all. So middle, if it's smack dab in the middle of the data, it doesn't change. Because it's not in an extreme value, really. It's just in the middle. It's kind of plain. It's along with everything else. And then the last thing, which we already touched on, is that R is the measure of X and Y being linearly related, so not curved. So even if they're related, they're not linearly related. Okay, I want you to write this in bold in the biggest font possible. Correlation does not imply causation.
Where do we write this?
Anywhere you want. On your, like, tattoo it on your arm or your forehead or something.
But if I tattoo it on my arm, wouldn't that be cheating?
No. Because I would value the dedication to this class.
Alright, I'm writing.
Okay, so if they try to
Put it at the bottom.
So if they try to suspend me for a tattoo, I'm gonna need you to.
I'll vouch for you.
I don't even know what the statement means, but
Okay, if I say two things are correlated, that does not mean that it causes something to happen. One does not cause the other.
Yeah,
So the number of hours you studied does not cause you to make 100.
I don't know.
Here's some ridiculous examples that actually have a really high correlation. If you were to look them up, statistically, they have a very high correlation. But that doesn't mean that. Ice cream consumption has a positive correlation with drowning rates. Does that mean that eating ice cream causes drowning?
No.
No.
Okay, but what does that mean?
it's a cause, right?
Like the more,
You can sit at home and eat ice cream, and you never get near a pool. If you drink too much, what does that mean?
like the cities that have a lot of ice cream consumption have a higher drowning rate.
Well, that's because
Because you get the ice
people.
That's correlated.
That means they're bigger people.
That could, yeah, that could be it.
Yeah, that's what
People eat ice cream by the pool and they drown more.
I know, but like not during the summer, you eat it inside.
Also, another reason could be that there's a lot of ice cream in places that are warm, and then there's water where there's warm. You know? No, I'm going to put a big no. Okay, the next one, the sales of lawnmowers are positively correlated with warm temperatures.
That's true.
Does
Because
that
means
mean
the grass will grow?
that lawn mowers cause global
If
warming?
you think about it, yeah.
First of all, you pulled global warming out of everywhere.
It's
Out of
called
nowhere.
climate change. Now it's climate change.
Climate change. Does it cause climate change?
Wait.
Okay, but all you asked was about warm temperatures.
That makes
Nothing about
sense.
global warming.
Does it mean that it causes?
You change temperatures to global warming.
But warm temperatures,
You can't do that.
does it cause global warming?
What?
Okay.
Wait.
That's like the comment you
well,
just made.
Well, okay, wait. If it's like if you're in a really, really cold like area, like your grass is like gonna die, not like grow.
So that's why they're correlated, but that doesn't mean that it causes it to happen.
No,
So that's the
so
whole point.
warmer weather causes the sale of lawnmowers because when warm weather grass grows.
Yeah, that
Don't cause the outside to become hot.
Yes.
No.
No, but if you were to flip that sentence,
Yes, if you
warm
were to flip it, it'd be
weather
different, but it's the way it is.
lawnmowers.
Okay, next one. Okay, there's another one though that I read the other day
I
that
was just.
there is like a 99% correlation between the consumption of hot chocolate versus low crime rate. So the more hot chocolate
What?
that is sold, the less crime.
Where do you get this from? Because I know that information.
So if we all drink a lot of hot chocolate, then there won't be any crime.
Bacon, you should just say, "Can you give me this free hot chocolate?" Probably not go wrong.
Yes, he is.
Here's some not so ridiculous examples.
Where were you going with that?
Okay, we're gonna skip. Now,
Wait, no, go back on that
back.
one because the first sentence on the not so ridiculous, that's actually true and I've done the research.
that doesn't mean it causes it to happen. There's no causation.
Has caused the temperature to rise.
Okay, next question.
And
We're gonna
I did
match.
a whole paper on global Friday.
We're gonna match these with their scatter plots. So these are values. What I want to do first, is go through and label the strongs, the weaks, and then perfect. Okay, so A would be strong negative. Strong negative.
Oh, you're talking about that?
Yeah, I'm just looking at the A, B, C, D. A, B, C, D. So B would be weak, negative.
Perfect.
C is perfect. And then D is strong, negative. And is it stronger or less strong than A? A is stronger because it's closer to 1.
A.
I want to be close.
Yeah, then D.
So number 1, is that the perfect one?
C.
Perfect, so C. Number 2,
A. B.
wait, isn't this one better than 4? This one's better than 4.
You're better.
So that would be D. D. This one is stronger than this one, right?
We just said A. A is closer to negative.
Was closer to 1.
No, D is closer to negative 1.
You just said
that.
You said A was closer.
Maybe you just don't remember saying it, but it did
You
happen.
did say that.
Okay, cool. Thanks.
It's on the video.
Go prove me wrong. It's fine. Okay, C, D, B, A.
It's just A, B, C, D dots.
Perfect.
No, it's actually not. C.
No.
Good try.
Okay, what I want you to do next, this definition. So the coefficient of determination is R squared. So it's basically taking your R value and squaring it. And you think, why in the world would we do that? So what that is it's the variation in the y that is explained by the least squares regression line. So
What?
let me explain the scenario of what that means. So we go back to my example talking about hours studied versus your grade you get on the test. And it looks like this. And let's say I get an R squared value that is 80 0.802. What that means, in interpreting this without all the crazy language, that 80.2% of the reason why you made the grade that you made is because of how much you studied. The other 20%, So this is due to hours. The other 20% is due to other factors. Like, what are some other factors that can help with what grade you made on the test?
Crack,
Sleep, food, etc. That's all the other junk. But 80% of the reason why you made what you made is because of how much you studied, okay? So that's how to understand it. But when you're interpreting it on a test or on a quiz or anything like that, here is what you're going to write down. I'm going to create a little script for you, and all you have to do is memorize it. So blank percent, which will be your r squared, percent of the variation in y, which will be context. So I'm going to underline it because you're going to insert context. So 80% of the variation in the grade on the test can be explained by the LSRL, which you haven't exactly learned yet. We're going to learn next class, but for right now, just write it down and then it will all make sense.
Is that a context thing or LSRL?
Yeah, the least squares regression line is what it stands for, which is basically like your line of best fit. Yeah, but put LSRL. So write this verbatim. The only thing you'll insert is the r squared and the y. So it looks exactly the same as your, like when we're matching. So on the next example, it's going to be kind of the same, but now all r squareds are positive. So you just have to order them from the least, like the weakest to the strongest. And the direction doesn't matter, okay? So this one is a little bit trickier because positives and negatives, you can't really separate those. They're going to be positive and negative, but all of these are going to be positive. They're all going to be between 0 and 1.
So say like
So
we had a number like it was like 0.58 and like 0.68, and we may have flipped it, but it's like super.
It'll be pretty obvious.
Okay.
So if I'm ordering it from weakest to strongest, it would be D, A, B, C. So now looking at my pictures, I want to match which one's the strongest, 1, 2, 3, or 4. Four is perfect.
Wait. It's C.
Oh, sorry. I know I'm confusing you.
D is the strongest. Otherwise,
D is the first one.
So
And
B.
D is the first.
D is the first one,
The back.
And then B, and then
then A, then C.
The back.
That back.
B back.
Perfect.
Or it's that.
Back.
Correlation between height and weight is R equals 0.40 for 12th grade male respondents. There's 1,501 of them. Calculate R squared and write a sentence that interprets this value in the context of the situation. So it gives me R, which, side note, I want to interpret R as well. So I'm going to say interpret R as well. That we're going to do both of them. If I were to just interpret R, what would that look like?
Height and weight is
Yes.
40%.
This is the LSD for R. So if I'm interpreting R. There is a
Linear weak
linear,
positive.
weak, positive correlation between height and weight for 12th grade males. That's what the problem tells me. 12th grade males. Okay, so that was like, I guess, before A. Now, second part, calculate R squared and write a sentence that interprets it. So, if I want to calculate R squared, I just got to take 0.4 and square it, which is what? 0.16. So let's go back to our script and turn this into a percentage. So 16% of the variation in y. What is our y here?
And
Weight.
wait.
It tells me. Can be explained by the LSRL, which we don't know yet, but essentially it's like the line of best fit for all of the points, which we're going to learn
Wait,
next
okay,
class.
so for SLRL, when we learn it, do we actually have to put something there, or is it just
It's
always
LSRL. LSRL. Okay, B. Heights and weights were recorded in meters and kilograms. If I changed them to be inches and pounds, what would that do to my correlation coefficient? It would stay the same. Y'all are so smart.
I know, Miss Monroe.
Because I would just be, it's like a linear transformation.
Wait.
It'd stay the same.
I had like
Literally just write the word same.
other people had gross part ones. I had
Example, it gives us a set of data. We're going to sketch a scatter plot. Then we're going to calculate and interpret the correlation coefficient of determination. So we're going to do this all in our calculator first. Then I'm going to show you how to do it in the computer so that you know how to do both of them. So let's start with calculator. Start with calculator, where you're going to put your expenditures in L1, graduation rates in L2. So here we are, we have our two lists. Someone remind me how to make a scatter plot.
second star plot.
Second, y equals,
It's on.
zoom 9. And so I'm going to draw it. It looks kind of funky, but I'm going to go with it.
That's what mine
So
was like.
I'm going to label my axes.
Wow, that is a weak axis. Non-linear. Weak
But when you have multiple plural, it's axes.
I thought it'd be XI.
No.
Axis is.
No.
The
Okay, what's my x-axis?
expenditures.
Expenditures. What is my y-axis?
Expenditures.
What's my y-axis?
Graduation rate.
Expenditures is like how much it costs. So
Expenditures.
the prompt essentially, we're trying to see, listen, stop. Trying to see if there is a relationship between how much it costs to go to a college versus the graduation rate of the college. Like basically how many started at their freshman year and then finished out percentage wise. So they're trying to see like if it costs more money, do people stay or do they most likely leave and transfer somewhere else or not finish, which is very sad. So this would be the scatter plot. All you need are to label and then draw the points. I'm going to show you how to calculate your correlation coefficient and your coefficient of determination, so R and R squared. So I'm going to, first everybody needs to go to mode really quickly on their calculator and make sure, like scroll down and make sure that your stat diagnostics are turned on.
Where is that?
So hit mode.
Where do I
If you have an Inspire, you don't even need to worry about it because I think it's already
What I
on.
gotta do? Oh,
Hit mode and make sure your stat diagnostics are turned on, and they should be.
how do I make sure that's turned on?
You go to mode.
I did went to mode.
Okay, from here, everyone listen, focus.
Turn them on.
I'm not going to go until I see everybody's eyes looking at me. Thank you. You're going to go to stat. You're going to go to calc. You're going to go to linear regression. You can either do option 4 or option 8. Either one is the same, but the A and the B are just switched. So once we get to the line of best fit, I will help you out next class. But for right now, either option 4 or option 8, it does not matter. I'll use 8. You keep list 1 and list 2 the way it is. There should be nothing in frequency. And then you hit calculate.
Oh, that's sweet.
And here it gives me my R and my R squared. And it's very, very weak.
That's what I said.
Very, very weak.
Do we need to write all that down?
So I want you to write R equals and r squared equals, and then we're going to interpret it.
How many decimal places you want to go out?
Go out 3 decimal places. 3 decimal places.
Are all the ones that we do like this gonna be
You said linear or regression?
Do what?
Are all the ones that we do like this gonna be linear?
So r equals 0.05. How do I interpret that?
No, come back. No, help me.
There is a positive, weak, linear correlation, because it's 0.05, between expenditures and graduation rates. R squared is 0.002425, something like that. So
You must not round the 2 to the 3.
I did 0.003 because you said 3 decimal places.
right, 3 decimal places. It didn't round up. It's like 0.24.
I was 2.9. You get 5. It was 2 something.
24. It didn't round up.
Oh.
You can just leave it as 0.002 if that works.
How do you find it on inside?
I don't know. I'll have to find it in a minute. Okay, from here, I say I'm going to convert this to a percentage. So what would that be if I move it over 2 decimal places? 0.2% of the variation in what? Yes, graduation rates.
You always do them.
Can be explained by the LSRL, which you actually in your calculator found the LSRL, mx plus b, which is your line of best fit. But we're not going to do that till next time. Okay, what I want you to do now is, I want you to take the data that you have and I want you to follow the steps on Excel so that you know how to find the R and R squared in Excel. Because like I said, on MyMathLab, they're going to give you like 100 data points and you don't want to try typing those in. So the steps are on there. Try finding the R, just try finding, like going through the steps, and then I'll explain what everything means in a second. So let's say you technically were able to do this on Excel.
Which we cannot.
Which I will figure it out for you. It's going to show up something like this. And the only number that you will need
Is R squared.
is R squared. You don't need adjusted. You don't need any of that. So we're just going to cross it out. I don't know why it's there. It's there to throw you off. All we need is R squared. That's our R squared. 0.495. Just go 3 decimal places.
49.5.
So, interpreting 49.5% of the variation. Do we have context? So we just put Y. Can be explained by the LSRL.